everyone, we are talking about special right triangles today. These are really important because they kind of form the basis to basic trigonometry. Right, so there's two special right triangles we're interested in, which are the 45-45-90 and the 30-60-90. And these are the angle measurements of our triangle. So you'll notice that they're both right triangles. One of them is an isosceles triangle, 45-45-90 degrees, and the other is a 30-60-90 degree triangle. Okay, and these are special because the sides will end up having a specific ratio, and it makes it really easy to figure out the different sides of the triangles if you know the angle measurements. Alright, so our first triangle naturally occurs if we take a square and divide along the diagonal, then we'll get obviously our right angle here and two 45-degree angles. Right, so those will be equal. Our second special right triangle occurs if I divide an equilateral triangle in half along the altitude. So I'll have my 90-degree angle there. This will still be 60. And I've divided a 60-degree angle in half, so this will now be 30 degrees. Okay, so a little bit of exploration. So I want to find the hypotenuse and the angles given that these are both 5. Well, I know that the opposite angle will always correspond with the opposite side, right? So my angle here will correspond with 5. My angle here will also correspond with 5. Because this is an isosceles triangle and my sides are the same, I know that my angles must also be the same. So these will both be 45. Okay, now I need to know my opposite hypotenuse here. So I can use the Pythagorean theorem. So 5 squared plus 5 squared is equal to c squared. That means c squared is 50. So c must be the square root of 50. And as we practiced earlier in the unit, that's going to be 5 root 2. Okay, let's see what happens now if I solve just in terms of x. So same thing, I'll have c squared equals x squared plus x squared, which is 2x squared. Now if I take the square root, that will be the square root of 2x squared, or just x root 2. Now let's notice some commonalities here. So I see the legs of my isosceles triangle were 5. I ended up with a 5 in my hypotenuse. Same thing here. I had x's as the legs of my triangle, and I ended up with my same x here in my hypotenuse. Okay, so this is just for any number x. And notice what I had left over was a square root of 2, and this will actually always occur. So what I can conclude is that my pattern is going to be x to x root 2. We could say 1 to 1 to 2. The square root of 2, I should say. So our ratios between the legs are always going to be x to x root 2, or 1 to 1 to the square root of 2. Okay, however you want to think about it. Alright, so how do we use this? Well, depending on what information we have, we can use that ratio to solve for the missing pieces. Okay, so if I'm starting off with a leg, I can just multiply that leg length by the square root of 2, and that will give me my hypotenuse. If I'm starting with the hypotenuse, we just divide by the square root of 2 to find the legs, right? So that fits in my ratio. So, first example, I'm given these sides. I have 6. I know this is a 45, 45, 90. So I know that my other leg must be 6. I know the hypotenuse is going to be 6 root 2. And that's it. I'm done. Okay, go ahead and pause the video and give these other two triangles a shot. And when you've done that, you can unpause and check and see if you got what I got. Okay, so hopefully you got the same answer. I know that this is an isosceles triangle, so 3 and 3, and then 3 root 2 will be my hypotenuse. On my last example, I started with the hypotenuse, so I'm just going to divide by the square root of 2 and get my remaining legs. Alright, so we can always set up a ratio. I think it's equally easy to just divide. It's kind of up to you. So there's a few ways that we can do this. I'll show you 2 ways. First of all, I have my ratio like we talked about before. So I can set this up 1 to 1 to the square root of 2. And this is always going to be, obviously, leg to hypotenuse. Okay, so in this case, my hypotenuse is 10. So I need to end up making this ratio have a 10 at the end here. I don't want to square root of 2. So what I can do is multiply by 10 and then divide by the square root of 2. Okay, and that would apply to everything in here. You can treat this kind of like an equal sign. It essentially works the same way. So if I multiplied everything by 10, I would end up with 10 to 10 to 10 root 2. And if I divided everything by the square root of 2, I would get 10 divided by the square root of 2 to the 10 divided by the square root of 2. That should be a 2. To 10. Right? So I got what I wanted as my hypotenuse, which is 10. That means my legs must both be 10 divided by the square root of 2. As we practiced before, we don't want the square root of 2 in the denominator, so I'm going to rationalize. I'm going to multiply both the top and the bottom by the square root of 2. And I'll end up getting 5 root 2. Alright. Hey, alternatively, I could have just straight divided by the square root of 2 using my rule from before. So I know that my hypotenuse is 10, so that means that each of my sides must have been 10 divided by the square root of 2. Right, that's my rule. And then I would just rationalize, again, get 5 root 2. Totally fine. Okay, go ahead and give that a shot. We have 2 examples here, so pause the video and see if you can get the same thing that I do. Alright, so hopefully you got this. On our first example, we're just going to divide 18 by the square root of 2. So I'll end up with 9 root 2. My second example, I can multiply by the square root of 2 to get my hypotenuse. My other leg will just be the same. So I end up getting 7 root 12, and as I know, I can take a 4 out of this. So the square root of 4 is 2. 2 times 7 is 14. Okay, moving on to my 30, 60, 90 triangle. We'll do the same thing. So let's first explore using the Pythagorean theorem. I want to find my missing leg. So I'll set this up as 7 squared plus, we'll call that b squared, equals 14 squared. Hey, if we know our perfect squares, I know that b squared is, this is 196 minus 49, right? So that's going to give me 147. Alright, now if I take the square root of both sides, I'll end up with the square root of 147, which actually is a multiple of 49, right? I can actually take multiple 7s out of this. You can see that kind of from the get-go. 14 and 7 are both divisible by 7. So this will end up reducing to 7 root 3, interestingly. And in terms of our pattern, I'll give you a hint that 14 is the same thing as 7 times 2. And let's notice the commonalities here. Alright, same number there. And what I have different is I have this 2, I have this square root of 3. Okay. So what ends up being true is always our shortest leg, right, which is opposite my 30-degree angle, always my shortest leg is going to be my x. Sorry, use a different color. Okay. My hypotenuse will always be double this length. my longer leg, so the leg opposite the 60-degree angle, will always be x times the square root of 3. X times the square root of 3. Alright, so my pattern here, if I was using 1, would be, I could also write this as 1 to the square root of 3 to 2. Right, or x to the x root 3 to the 2x. Right, so that is the relationship or the ratio between all of my legs and my hypotenuse. I should say all my sides. So it makes it easiest to find the short leg first. If you're given the longer leg, you're going to want to divide by the square root of 3, which can get messy. But it does help having that. Because I don't have a, well, you can have a direct relationship between the longer leg and the hypotenuse, but it just makes it easier to have the shorter leg if you don't have it. Alright, so starting off, I have 8 as my shortest side, so I automatically know 16 is going to be my hypotenuse. My longer leg will be 8 root 3. Okay, now if I'm starting out with the hypotenuse, then I know that 8 is my hypotenuse, so half of that will be my shorter leg. And then my short leg times the square root of 3 is going to be my longer leg. Okay, now if the sides are not obvious, again, you can always set up a ratio. So if I am starting with my longer leg, not inherently obvious what's going on. In order to find the shorter leg, I'm going to end up dividing by the square root of 3. So we can keep this ratio in mind. Now this is my shorter leg, this is my longer leg, and this is my hypotenuse. In this case, my longer leg is 5, so if I wanted to make the middle of my ratio 5, I would first divide everything by the square root of 3. Okay, and I want this to be 5, so let's multiply everything by 5. Okay, and this gives me all of my legs, both of my legs and my hypotenuse. Okay, so I end up with 5 as my longer leg. 5 divided by the square root of 3 is going to be my shorter leg. Okay, and we'll rationalize that to be 5 root 3 over 3. And then my longer my hypotenuse will be 10 divided by the square root of 3, or 10 root 3 over 3. Right, so you can give these a shot. Go ahead and pause the video, see if you got what I got. So hopefully you got the same answer. So over here in our first example, I'm going to divide by the square root of 3 because I need to find my shorter leg. And when I rationalize, I'll get 3 root 3. Double this is just 6 root 3 for my hypotenuse. Right, over here in my second example, I'm starting with the hypotenuse, so I'm first going to divide by 2 to get my shorter leg, and then multiply by the square root of 3 to get my longer leg. So that'll give me 4 root 18. I take a 9 out of this, so I'll end up getting 12 root 2. Alright, so let's put it all together. Just as some last practice before you move on to your worksheet. Again, you can ignore this. This is not your homework. Alright, so we have an isosceles triangle here, so I know this must be 45, 45, 90. So I'm going to divide by the square root of 2. I'll get 9. Right, next one. I have my longer leg as 6, so this must be a 30, 16, 90. So I know that 6 divided by the square root of 3, or if I multiply by the square root of 3, that'll give me 2 root 3, is my shorter leg. Double that is 4 root 3. Okay, now my longer leg is 5 root 3, and I know that this is my longer leg even though the orientation is different because it is opposite the 60-degree angle. So my shorter leg is going to be just 5, right? We divide by the square root of 3, and then I double this to get my hypotenuse, so 10. Okay, over here, another 45, 45, 90. I'm going to divide by the square root of 2. end, I will end up with just 7 root 2 over 2. Another 30, 60, 90. I have my longest side here, so this will be 13 divided by 2, or 6.5 if you wanted to. And then, from my longer leg, I will multiply by the square root of 3. Okay, another isosceles triangle, so my other leg will be the same, and I'm going to multiply by the square root of 2 to get my hypotenuse. And the nice thing is, if I multiply by the square root of 2, the square root of 2 times the square root of 2 is just 2, so 3 times 2 is 6. Alright, your homework is below. Let me know if you have any questions. Otherwise, have a fantastic rest of your day.